Hey everybody, welcome back. Today we're moving on to 10-4. 10-4, theoretical probability. We've dealt with experimental probability in the past, that last lesson, but today we're going to be talking about theoretical probability. We're going to be learning to estimate probability using theoretical methods. Notice that word theoretical has that word theory in it, not what has actually happened. Experimental means what has actually happened and basing our prediction on what's happened in the past. Theoretical means what is possible. Is it possible that this is going to take place? Okay? All right, so I have two things that you can write down: theoretical probability and equally likely. So please write these two down. All right, so theoretical probability estimates probabilities. You are estimating the different probabilities. You are making certain assumptions about an experiment. You are looking at this and you are kind of making predictions about what could happen in that experiment. Not what has happened in the past, because it's like you haven't done it yet, but what could possibly happen. Equally likely means having the same probability, so both of them have percentages. Today we're going to be dealing a lot with fractions, and here is why. Please write this fairness piece down and that equal probability for equally likely outcomes. This right here, this bottom piece, star that, bold it, read it right before you go to bed, dream about it, learn it, love it. All right, so we have fair. Fair is when all outcomes are equally likely. So if something is fair, it is equally likely. When you say something is not fair, a lot of times that's because you think somebody's being biased or it's not fair that you have to go here rather than stay home. It's not like I haven't heard that before. Okay, so when you look at that, fair means things are equally likely. All right? Then you have the different probabilities. The theoretical probability of an event. What I want you to know is that N, right here in that red box, that N stands for all of the possible outcomes. So that N stands for possible outcomes. Not just one, not just two, every single one of them. Then your number of outcomes in the event, the actual thing that you want to happen. Actual thing you want to happen. So let's try a problem. Please write this down. Okay, so if you look at this, it says an experiment consists of spinning this spinner once. You're only doing it once. Find the probability of each event. So if you look at this spinner, we have the outcomes of 1, 2, 3, 4, 5. We have those outcomes. If I spun the spinner, that's the only thing I could get. 1, 2, 3, 4, 5. So, when you look at this problem right here, where it has P on the outside, 4 on the inside of our parentheses, you are asking the probability of getting a 4. So, out of those 5 outcomes, how many times could you get a 4? Once. All right? So, if you go back to that previous slide, you put the total number of outcomes. How many outcomes do you have? Well, we have 5 possible outcomes. If I wanted to get a 4, what is the probability, the theoretical probability of getting that 4? 1 out of 5 chance. I didn't get that actual 4. That's the theoretical, what I could possibly get out of those 5 answers. So the probability of 1 is very similar. How many times do you see that 1? 1 out of 5. 1 out of 5, 1 out of 5. Then the probability of an even number coming up. So if I came up here and looked at these problems, 1, 2, 3, 4, 5, not these problems, these outcomes. What is the probability that I have even numbers? How many even numbers do I have? Dos. I have 2 even numbers. Okay, 2 and 4. How many total outcomes do I still have? 5. 5. This is like a bilingual math class. Gotta love it. Learning Spanish with the math. Okay? Then you have odd. What is it? Odd? Well, there's 3 odd numbers, 1, 3, and 5. So this one's 3 out of 5. Then the probability that you get less than 4, so you think to yourself, is 1 less than 4? Yep. 2 less than 4? Yep. 3 less than 4? Yep. 4 less than 4? Nope. 4 is equal to 4. So 1, 2, and 3 are the possibilities. Again, we have 3 out of 5. Okay, so you're looking inside here to see what your top number is. What your bottom number is, what your numerator is what's inside the parentheses. What your denominator is how many possible outcomes. Awesome. Okay, so it says an experiment consists of rolling one fair number cube and flipping a coin. Think about the possible outcomes. What could I possibly get if I roll a number cube and flip a coin? Roll a number cube and flip a coin. I want to see if you could do this one yourself. So pause now, try this one on your own. All right, so if I rolled a number cube, a number cube being a die, okay? So if I rolled a number cube, what could I possibly get? I could get a 1, a 2, a 3, a 4, a 5, or a 6, okay? Now, if I flipped a coin, I could get either heads or tails. So that means if I rolled a 1, I could get a heads as well. If I rolled a 2, I could also get a heads. If I rolled a 3, I could get a heads. Roll a 4, I could get a heads. 5 heads, 6 heads. Am I always going to flip a heads? No, I could also flip tails. So I could also get 1, 2, 3, 4, 5, 6. I could also flip tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. I can not only just flip a 1 heads, I can also flip 1 tails. And a 2 and a heads, and a 2 and a tails. I'm rolling the number cube and flipping the coin at the same time. Okay? Pause now. See if you can answer this problem. All right, so as you look at this, an experiment consists of flipping 2 coins. Okay, you're going to flip those coins, 2 coins. All right, so as you look at this, with these 2 coins, what could you get? If I flipped 1 coin, what could I get? A heads or a tails. All right, well, if I flip that second coin after I flipped my first heads, what could I flip next? Well, I could flip a heads and a tails, but I also could flip a heads and a heads. And my bottom one, I could flip a tails and a heads, and a tails and a tails. Those are my 4 possible outcomes. If you want to think about it as a tree diagram, I can flip heads and tails. After that, I could flip heads or tails, and heads or tails. So I have these different things. Now, as I look at this, 1 head and 1 tail. So if I look at my list, or I look at my tree diagram here, how many times did I flip at least 1 heads and at least 1 tails? 1 here, 1 here. How many total? 2 out of how many possible outcomes did I have? 4. Simplest form, 1/2. What about both of them being tails? Well, if both of them are tails, how many times in my sample size that you see down below did I get both tails? Once. 1 out of, again, how many times did we, or how many outcomes do we have? 4. So you're putting the number on top that you are choosing, that what's in parentheses. And your bottom number is the total number of possible outcomes. Good. All right, you don't have to write this one down. It says Carl has 3 green buttons, 4 purple buttons. How many white buttons should be added so that the probability of drawing a purple button is 2/9. So when I look at this problem, we need to add buttons, all right? We want my final term to be 2/9. I want my final probability to be 2/9. So something has to equal 2/9. However, if I wanted to figure out purple buttons, I need to figure out, well, if it's purple buttons, I need to have 4 on top because there are 4 purple buttons right now. 4 purple buttons. That's what I'm focused on. My probability of getting a purple button out of this bag or out of this collection, okay, I want that to equal 2/9. So right now I'm sitting at a total, if I were to look at my problem right here, the probability of me picking right now a purple button out of the total number of buttons he has is 4/7 because he has 7 total buttons. However, if 4/7 is not the same as 2/9, so what we have to do now, okay, what we have to do is we need to figure out how many buttons need to be added to my total to get a 2/9 solution. So what I end up doing is I take my 7, which I have my total, and I add x. So I add x to my total already of 7 because I need to improve that 7 on bottom to answer my final problem. To answer how many total I need to have to get a probability of 2/9. So what I do here, this appears to be, this is a proportion, cross multiply, I get 36. Then on the other side, I cross multiply again, and I get 2 times 7 plus x. What do I have to do in order for me to answer this problem? I need to distribute, and I end up with 36 is equal to 14 plus 2x. Get rid of my 14. And now I have 22 is equal to 2x. Divide by 2. And I solve for x, which is 11. How many white buttons need to be added to this? 11 white buttons. If I added 11 white buttons to my already, my total already, I would come up with a probability of 2/9 of picking out a purple button. All right? All right, so let's try one similar to this. All right, so write this one down and answer. Write down and answer. Try to see if you can come up with an equation for this. If you're not sure, just follow along to what I do. All right, so as I look at this, Stephanie has 2 dimes and 3 nickels. How many pennies should be added so that the probability of drawing a nickel is 3/7? So I want to equal 3/7. That's the probability I want. Okay, currently I have a probability of 3/5. How do I know that? Well, I have 3 nickels and a total of 5. But I need to figure out what needs to be added to change that 3/5 to 3/7. So I keep my 3 on top, and on bottom I have my total plus the number of pennies I'm going to add, because I'm going to add something to my total. So as I do this, I cross multiply. I take 7 times 3 and 3 times 5 plus x. After I distribute, I end up with 21 is equal to 15 plus x. Subtract 15 plus 3x. Subtract 15. Opposite operation, don't forget that. 6 is equal to 3x. Opposite operation of multiplication is division. X is equal to 2. I go through all of that formula. Once I have the equations, I go through my proportion step by cross multiplying, then inverse operations the whole way down. All right? Awesome. Let's move on. Okay, please write this down. These are what's called mutually exclusive or disjointed events. Do not worry about what's in red. Do not write down what's in red. Should you write down what's in red? No. All right, so mutually exclusive or disjoint events. Okay, they cannot occur at the same time. For instance, If I said something along the lines of that I will flip I will flip a heads and a tails at the same time. Well, if I'm using 1/4, it won't happen. Okay, same thing if I am rolling a die and I want to roll a 1 and an even number. That can't happen because 1 is not an even number. Those are disjoint events. Okay? So you use, if one or the other can occur, you use the probability of A, so you'll get a fraction plus the probability of B. You'll get another fraction, add them together, and you'll get your probability of both. All right, so you have this problem. Do not write this down. It's longer. You guys have written enough today, so do not write this down. Just show your work on the problem. It says, suppose you are playing a game in which you flip 2 coins. You flip both heads, you win, and if you flip both tails, you lose. If you flip anything else, the game continues. What is the probability that the game will end on your next flip? So remember, it ends, whether you win or lose, it ends by getting 2 heads or 2 tails. So our probability, what we want to do is we want to find the probability of game ends. Okay, and we find that by finding the probability of getting, well, how do you win? By getting both heads. And how could you lose? By getting both tails. Okay, so when I look at these problems, the only way I can win or the game ends is if I get both heads or both tails. All right, so we talked about this before. I'm flipping 2 coins. What are the possible outcomes I could have? Well, I could flip a heads, then another heads. I could flip a heads and then another tails, flip a tails and then a heads, then flip a tails and a tails. So I want to figure out of these 4 outcomes. Remember, this is the total number. Both of them are heads. Well, as I look up top, I have 1 out of 4 that have both heads as my fraction. So I take 1 out of 4. Okay, 1 out of 4. I am going to add that because I'm figuring out either I'm going to win or I'm going to lose. One or the other will occur. So 1/4 is the probability of both heads landing. Probability of both tails landing is again 1/4. When we are figuring out if one or the other will occur, I add their 2 probabilities together. Okay, I add these together. So when I find that out, I end up with 2/4, which is equal to 1/2 or 50%. Okay, so when I look at this, I will either lose the game or lose the game or win the game. It has a 50% chance of the game ending completely. 50% chance on these next flips. That's all I have for you today. I hope you have a wonderful day. I will talk to you later. We'll discuss this lesson a little bit more further tomorrow. Have a great day. Bye.